what we're really interested in using is what's often called a spatial computer, or sometimes mixed reality. And you can see from this graphic, you know, you're not in a fake world with an astronaut, with a virtual astronaut. You're not in a cell phone world with a virtual astronaut. The virtual astronaut is in your world using these technologies. So it's an opportunity for us to use this for training, for first response, and disaster settings and pandemics, and take your pick. But the really exciting potential of this technology is that it's the real world, but with virtual elements. So that lets you train people for how to navigate real space, get used to operating in the confines or the expanse or whatever characteristics of an actual environment, but then giving us the flexibility to do any scenario we want at any time with really low cost, but extremely high possibility. We're opening up a whole new dimension of being able to train really complicated scenarios, even for regular people who wouldn't normally be able to get access to sort of government level multi-victim casualty. I think on the next slide, I think there's a quick video that just shows this in action. So you can see that it's the real world, but with virtual elements. These are very cartoony elements. And the thing about we call it our holo triage because it's holograms and you're learning how to do triage. There's different fidelity levels to this simulation. You can use more cartoony graphics and kind of like here you see it's just quick touch and do the procedure. I'm listening and feeling for breathing, right? So then it gets up to the higher levels where we use more advanced graphics and more precise hand interactions and precise things. But this is a very unique thing. In order to do a scenario like it's being shown in this video, you would have to either have 3 mannequins or 3 people that are trained how to behave this way. So now we can instantaneously set up in a real environment these virtual elements and go around and work on them and basically, for lack of a better term, kind of gamify multi-victim casualty training. So you can see then you can integrate. So that's where the real med bag is. So you get people used to go look for the real supply in your real building, but don't have the cost of actually getting the bag out and doing this stuff. Don't have the cleanup, you know, put the tourniquet on the leg. And so you see here, it's like you have this opportunity to bring people in at the abstract level and then a really clean progression all the way up. So this just keeps going. And obviously I save all these victims because I was the one who wrote the scenario. But, you know, that's the fun part about this too, is that then people who design these scenarios professionally get this canvas to be able to design scenarios. So you can do learning anywhere. And moreover than just kind of these prepackaged scenarios is the opportunity to bring in these characters that represent real people. So a real trainer, especially right now, this opportunity exists to do this in your living room and have somebody, a real certified trainer, watch you do it as an avatar and create scenarios for you to work with, but it's your real environment. So it's this mixture that's going to characterize the future of computing, where no longer is the computer something you use, it's actually something we're standing within, which is kind of a fascinating thing. It's as if you stepped into the world being understood by the computer. That's why it's called a spatial computer. Where this is going. So training is just one step. But when we go out to space, when we even go out to remote and austere environments, and even in my personal experience being a ocean lifeguard for California State Parks, there's only so much training that any given person can be given. And then you get out there in the world and you've seen something, you're seeing something you've never seen before. So what we can do is use these technologies to create a real-time guidance paradigm where you're able to coordinate the location of victims, you're able to coordinate all the assets needed and all the understanding. So this graphic is meant to illustrate that you've got your bird's eye view, you've got your triangulation, and you have a remote expert somewhere else who is able to be present with you and walk you through the process. They have all the information they need from the scene based on all the incredible sensors that are built into these kinds of devices. And then you have this fully situationally aware external person that can walk you through things. And if you ever had to have someone tell you how to do something on a computer or over the phone or over the radio, it's really frustrating. It's a lot simpler when you can use your human faculties, like walking over and pointing at something or drawing over something. And these are the kinds of opportunities that we have with this computer. So what we see, the vision here of AvatarMEDIC, and it's connected to the Mars Academy, is because we prototyped this with space in mind. Because first of all, Earth is in space. And I like to half joke that the middle of Kentucky can sometimes be similar to the surface of Mars, in the sense of your access to these medical capabilities is limited. It's just limited in places where we would so-called call them rural or whatever. In fact, two of our founding team members are surgeons, and they're very passionate about using these technologies directly in surgery. They're pioneers. And they often bring up the statistic that 5 billion people do not have access to surgery on the Earth right now. So if we fix this problem for astronauts, we're fixing it for Earth. A paradigm where any medical procedure that needs to be done can be done anywhere, anytime, potentially by anyone, being guided through this kind of a paradigm. So our view is that in the future, responding to NASA's call for autonomous medical capability, every pane of glass, every headset, every pair of glasses, every helmet visor will know how to do medicine. And so anyone wearing that device or looking through that piece of glass will be able to get access to the AvatarMEDIC and have that ability. And this technology allows us to integrate the visual component and the pathfinding component with the direct intervention component of robotics. So this is our rendering for the still freshly underway Avatar X Prize. And so this is a competition sponsored by the Japanese airline ANA. I don't know if they quite understood how forward-looking they were when they wanted to disrupt air travel as a paradigm, and instead give people the access to embody a robot somewhere else as their means of traveling. So rather than physically move their body, move their senses over somewhere else to a robot. So naturally, we entered this competition to create a Medinaut, an AvatarMEDIC, some platform which you can drive and interact with and feel as though you are situationally aware and present so that you can do medical intervention. So the first version of this for the X Prize will be like a rover, effectively, be able to drive around. We have some telemedicine capability in a simple way of the sort of tablet on the top there. The spatial computer really helps unify the robotic system with the ability to actually program it and manage it. This is our way of also connecting the dots between having human operators, but then training these systems. Because the whole time we're doing all this stuff with AvatarMEDIC, a lot of it at first is going to be beaming an expert in somewhere. But each time you have the system learning what's going on, and it watches from real expertise. Because we have an opportunity here to basically get the skills that are needed beamed out using humans. And then the whole time that operation is going on, the machines are learning, the AI systems are learning, what does a real person do? Where do their eyes go on a victim? How long do they linger? How do they approach this? I mean, there's just like an infinite amount of data that will be gathered by doing this. We want to take this out of a rover and into the ability to solve the problems that we have where people don't have access to surgery and to other kinds of medical capability, being able to fly this thing out there. Okay, so it's a concept, there's a lot to solve. I'm loving the chat. I can see, that there are lots of problems to solve. But the core reality is that we need a way to get medical care to where it's needed, not always bring people back to hospital. We're seeing that especially now with COVID, right? We need to be able to interact with people where they are for multiple reasons. They could be inaccessible. They could be infected in some way. Or the hospital system can be overwhelmed, or there might not even be a hospital. So this is the opportunity exists to have a machine which will be able to do things like laparoscopy. Here you got here comes the little thing out here, right? We're going to miniaturize stuff like you may have heard of the Da Vinci robot and be able to bolt it onto a drone and fly it out to where it's needed. So trying to flip the paradigm so that make remote austere medicine as impactful and as powerful as hospital level medicine. So that's why it's our Mars shot. So we're taking it step at a time. The technology is still very new and in a lot of different dimensions, but this is where we see the future going in the 21st century, is that any medical capability, procedure, whatever you need at any time, anywhere.